Hello dear students of class 8, very good morning. Here I am going to start the next chapter, that is energy. Dear, in the last chapter we have understood about pressures, force, effect of forces. Now in this chapter we will discuss about energy of a body and how energy is calculated. Basically, what means energy? Energy is the capacity of doing work. Dear, here work is our first topic. Okay? So, first of all, we will understand about what is work and what is the difference between the work in physics and the work in day-to-day life. Dear, whatever be the activity we do in our day-to-day life, we call it as a work. For example, I am teaching here. You all, I am doing a work. Dear, you just on sitting on your reading table and just study book, it means you are doing work. But in physics, these activities are not called as a work. The mental activities, the physical activities, whatever we perform is called as work in everyday life. While in physics, only those activities are said to be as a work in which there is a displacement, there is a change in position of the object. For example, I am pulling this board or pushing this board. Okay, dear? I am applying force on this wall and I exhausted. I lost my whole energy by applying force on the wall whole day. I become tired. I have lost my energy. It means I have applied force. But in physics, it is said to be as if there is no displacement to a body on which force has been applied, then it is said that there is no work done on that body. It means in physics it is said that if you are applying force on a body and body get displaced from its position in the direction of applied force, then we say that we have done some work on that body. Dear, for example, a camel pulling cart is called, it means that camel is doing work on cart. Means it is pulling and makes displaced from some position to another position. A boy cycling a bicycle, it means he is doing work. He is moving from one position to another position by applying force. Dear, so how work is said to be done only when a force applied on an object and makes it move through a distance in the direction of force. Dear, let us understand this activity, this line through our diagram. Suppose on a plane surface there is a box. Okay? I don't know what it marks, but there is a box. And you are applying a force F on this box. And box gets displaced from this position to another position, which is in the direction of force applied. Dear, which is in the direction of force applied. Box has moved from here to here. Let's suppose this is the position A and this is the position B. If you suppose that you are applying force F on this box, which has at position A, this box has moved to position B. Okay? And let's say that the displacement covered by the object is S. Okay? So we can say that we have done some work. You have done some work in displacing this object from A to B. There is a movement in the body from A to B. It has moved. It has covered some distance by the application of this force F on this body. That's why we said that we have done and you have done some work on this box. I hope you are able to understand this. Okay, dear? So, which type of quantity work is? Work is a scalar quantity here. It has only magnitude, no direction. Work is a scalar quantity here. Work is a scalar quantity. It has only magnitude. It has only magnitude, no direction. Now we are coming to the point how work is calculated, how work is measured. For example, as we know that work is a product of force and displacement. So here work, another definition you may also keep in your mind. Work is a product of force and displacement. Work is a product of force applied on the body into displacement. Covered by the body. Dear, you have to just remember it. This is the formula. Work is equal to force applied on the body into displacement covered by the body. Okay? So dear, as we have a good formula here, work is equal to force into displacement. Work is a scalar quantity, while force is a vector quantity. Force has magnitude and direction both. Displacement is also vector quantity. It is a distance covered in a particular direction. Displacement meaning of displacement, it is a distance covered in a particular direction. Means it has also a direction. Okay? So both are vector quantity, and the product of two vectors here is a one quantity, that is what? That is a scalar quantity. Okay? So we can write in short this formula as work is equal to force. Here arrow mentioned as a vector quantity. It is not necessary to learn you, but I am giving some more idea. Okay? And displacement. Here, this is the shortest formula. Here I have used point rather than this cross. It will help you in higher class to understand the difference between this and this. Now let us understand this is a product. Okay, not a point. It is a simple that you have to understand it as a product. Okay. So work has a formula of force into displacement. You get an idea. Now I am coming to the unit of work. Unit of work. Dear, SI unit of work is SI unit of work is joule. For contribution, joule has to remember joule be given as a unit, SI unit as a of work is a joule, because joule has contributed a lot of ideas about work and heat. Okay, he has developed many theoretical, experimental values to make us understand about work. There is a large contribution of his work has given a broad idea for development of work and energy. That's why to remember him, to honor him, we have given SI unit of work as a joule. Joule is a scientist. Okay. Now, if anyone asks you, what do you mean by 1 joule? Let us understand here. As we know that work is equal to force into displacement. Force into displacement. And we all know that the SI unit of force is Newton. Okay, that is denoted by N. And SI unit of displacement is meter, that is denoted by M. Okay, so SI unit of work will be Newton, force for Newton, and displacement for meter. Okay, the SI unit of work is Newton meter. You may write it as Newton meter. Dear, so SI unit of work is Newton meter. Let's suppose that 1 Newton meter is equal to, if you are applying a force of 1 Newton and the body has displaced through 1 meter, this is called as 1 joule. 1 joule is equal to 1 Newton meter. So there will be a nice question. Define 1 joule. It means that when a body is displaced by applying a force of 1 Newton, when a body is displaced by applying a force of 1 Newton by 1 meter, means displacement is of 1 meter, then work done on the body is said to be as 1 joule. In another way, we can also define it, the amount of work done. 1 joule is the amount of work done when a body is displaced by 1 meter on applying a force of 1 Newton on the body. Okay? So I hope you will be able to understand this. Okay? So here we have understand another bigger unit of work is kilojoule. Kilojoule means, dear, please understand here. Kilo means 1000. You have to understand it. Kilo means 1000. 1000 joule is called as 1 kilojoule. 1 kilojoule is equal to 1000 joule. Kilo means 1000, so we will take 1 kilojoule is equal to 1000. Now here, come to the CGS unit of work. CGS unit of work. CGS unit of work is arch. CGS unit of CGS unit of work is arch. There is a nice relation between arch and joule. Okay. So we will come to the point. What relation between arch and joule? Dear, as we know that 1 joule is equal to 1 Newton meter. So I hope you all know that 1 Newton is equal to, if you don't know, please learn. As we know that force is equal to mass into acceleration. So 1 Newton, if I say that force is 1 Newton, it means that 1 kg of a body has been displaced or moved with an acceleration of 1 meter per second square. Okay, means 1 Newton is equal to 1 kg meter per second square or 1 kg meter second inverse square. Okay, I hope you all know that about that. Okay, and we know that 1 meter is equal to 100 centimeter. You also know. So come to the point. 1 meter is equal to 100 centimeter. 1 kg is equal to 1000 gram. You all people know about this here? Because it is easy conversion. That's why I am coming to this point. So 1 joule is equal to, dear, please understand, 1 Newton. For Newton we can write it. For Newton we can write it kg meter second inverse square. Okay, and again a meter. Okay, so we can write it 1 joule is equal to 1 kg meter square second inverse square. Meter and meter will combine to become a meter square. Now 1 joule is equal to, dear, please understand, 1 joule is equal to 1 into, for kg, 1 kg we can write it as 1000 gram. 1000 gram. For 1 meter we can write 100 centimeter. 100 centimeter. As meter square है, so centimeter square. We will take as a centimeter square. Second inverse square. Okay? I hope you all will understand here. So 1 joule is equal to 10 to the power 3 gram. Okay, I am removing this. This will be of a square, as it is a square, 100 square. 100 square means 10 to the power 4. Okay, centimeter square means gram centimeter square second inverse square. Dear, 10 to the power 7, 10 to the power 3 and 10 to the power 4 will become 10 to the power 7 gram centimeter square second inverse square. Okay, 1 joule is equal to, and we know that 1 gram centimeter square second inverse square is called as 1 arch, is equal to 1 arch. Dear, 1 arch. Arch is CGS unit, so its all quantity will be in CGS, gram centimeter square second. That's why 1 arch is equal to 1 gram centimeter square second inverse square. So 1 joule is equal to 10 to the power 7 arch. This is not your syllabus, but I hope to make you more, to get you more idea. I have explained this all. Otherwise, I can simply say that 1 joule is equal to 10 to the power 7 arch. Dear, please learn this. This will give you more idea about that. Now I am coming to a solve example. In solve example, okay dear, we are going to do a question. Okay. Let us suppose that an object is displaced by 2 meters when a force of 50 Newton is applied on it. Find the work done on the object. Dear, it is saying that there is an object which is displaced from its position, okay, by applying a force of 50 Newton. The object has displaced through a 2 meters. Okay, it reached to point B. Okay, as displacement given here is 2 meters, and it is asking work done on the point. So we know that work is equal to force into displacement. So work is equal to force into displacement. Here force is of 50 Newton into displacement of 2 meters. Here it will become 100 Newton meter. This Newton meter will be called a joule. So 100 joule. Work done on the object will be 100 joule. It's so simple. You can do it by yourself. The second example. In the next class we will meet you with the next topic, that is energy. Okay, bye dear. If you have any problem, please ask on the Google class. Okay, bye.